Hi, welcome to our pre-calculus. The topic today is solving a triangle with the law of sines, problem type 1. So let me remind you what the law of sine is. At the end of this example, I'm going to give a brief proof of it. So we said our aim is to solve a triangle. A triangle has many pieces, at least 3 sides, 3 angles, and lots of other things. Solving means finding all these 6 quantities. Typically, some of them are given, typically 3 of them are given, and you want to find the other 3. One of the relationships that holds between these 6 quantities is that if you divide each length by the sine of the angle in front of it, so if I take this length and divide by the sine of angle in front of it, the fraction that I get is the same for all vertices. So if I take B and divide by sine of beta, or C divide by sine of gamma, or if you want to call them angles A, B, C, however you want to call them, you get the same fraction. And here's a basic application of this thing. So we have a triangle, and we are told that this is not drawn to scale, obviously not. A is 108, this is 108. C is 41, so of course this is not drawn to scale. And B is this one, this is 43 feet or meters or whatever it is. We want to solve the triangle, which means finding whatever is missing. Angle B, side A, side C, that's the quantity that is required. For the obvious arrangement, you see here we have an angle, a side, and another angle. So sometimes this is referred to as ASA configuration. Angle, side, another angle. That's the style of the problem. And I understand what it means by type 1, probably is in reference to that one. So it's very straightforward. A over sine of A is equal to, excuse me, well, straightforward, but I can still make a mistake. So little a, B over sine of B, and little c over sine of C. You make sure your handwriting, you don't confuse these two. This is the side and that's the angle. So let's just write the quantities we have and the ones that we don't have. So I don't have A divided by sine of 108. I do have B. B is given as 43 divided by sine of B. No, what is B itself? We know in each triangle on a flat plane, A plus B plus C is 180 degrees. So A is 108, B we want to find, C is 41, this has to be 180, so B is going to be 180 minus 149, that's the total, and I get 31 degrees. So the angle B we calculated, so this is calculated to be 31 degrees, so that the sum of all angles add up to 180, and that is equal to C divided by sine of C, which is sine of 41 degrees. So this is going to give you two equations, this one and then this one. Let me make sure this is readable. This is 31. So if you have A over sine of 108 is equal to 43 over sine of 31, just multiply by sine of 108, so I have A is 43 sine of 108 divided by sine of 31. Again, strong recommendation to type this thing in one single action in your in Alex calculator as opposed to breaking it up into pieces. You get the maximum accuracy and then lowest chance of making mistakes, and you build the confidence in translating from a written formula to something that's entered on a calculator. So you want to practice that. If you want to cut it into pieces and do it piece by piece, that's fine as well. Keep several digits so that you don't lose accuracy, and at the end you want to approximate to the nearest tenth. You see at the bottom it says if there's more than one solution, separate them with this or, and if there is no solution, well, then you enter that one. We are going to come up to those issues later on. In the case of ASA, you always have just one solution and then you just go ahead and find it. So from this other equation, you do the same thing. You get 43 sine of 41 divided by sine of 31. So these are the two sides. So we found B to be 31, and A and C, you enter it from the calculator and you'll be all set. Okay. So we learned that this is type ASA here we're doing. Next issue is, well, where does this one come from? Where does law of sines, what is the origin of that? In these beginning formulas, you want to push yourself to the next level of understanding where the formula itself comes from. Even though you almost never are asked to reproduce proof of these things, but it's very helpful. It's gonna build your mind for other stuff coming up. You want to go through the exercise of proving this thing, especially those of you who are majoring mathematics. This is a 100% requirement to be able to show where does it come from. If you are going toward any kind of design jobs in engineering, theoretical jobs and so on, that's also required. For field applications, do make sure that you understand how to apply it. So next issue up, so this is in addition to the problem, where does the law of sine come from? It's very straightforward actually. Let's draw a triangle. Let's consider this thing angle A, angle B, angle C. This is little a, this is little b, and we go ahead and draw the perpendicular from this point. Let's call this thing H. So I go ahead and look at this two triangles that I just made. One, let's call that the blue, the red one, and the other is the blue one. In the red triangle, what can I say? Okay, this is the angle. I can say sine of A is equal to H, its opposite, divided by hypotenuse, which is B. Therefore, H is equal to B sine of A. How about the blue one? Same thing. Sine of B is equal to H. Now in this one, opposite of this angle B is H again, and its hypotenuse is A. So H now is A sine of B. Now what? Now I say, well, these are same quantities, this is the same height. They have to be the same, so these two have to be the same. So A sine of B is same as B sine of A. That is in fact the law of sines. If you want to write it in the form that we had before up there, take both sides and divide it by sine A sine B. So I write sine A sine B. I can divide two sides of an equation by the same quantity. That's still an equation. No, sine of B is cancel, sine of A is cancel, and you get A over sine of A is equal to B over sine of B. Now we apply the principle of symmetry. If this is true between A and B, then it must be true between A and C and between B and C. After all these corners play the exact same role. So by extension, in that sense, this is same as C over sine of C. And if you don't believe me, go ahead and drop another perpendicular here and repeat the problem all over again. Okay, so we proved the law of sines. You want to learn that. Next question up. Well, the person who comes up with this proof, how does he know to draw that line? That's a crucial line that is drawn, and then you come up with an argument, and then you have the final proof. So it's a typical question as how do you know to draw that line? Well, if you are immersed in a topic for years and you keep constantly thinking about it, this kind of points of inspiration do come to you. Now, where does it come from? It becomes a philosophical question. Nobody can offer a kind of solid way as to how people come up with an idea or another idea. So all discoveries are subject to the same thing. So you stay on the track, try to learn the proof and try to reproduce the proof, and then after you stay with the topic for a while, and then these kind of things become second nature to you as well. Okay, so what we did here, we looked at the ASA type, angle-side-angle, for application of law of sines to solving a general triangle. Until next time, good luck and God bless.